Greetings, this is Rick Powers from Western Technical College, Basic Statistics, and I'm going to record Lesson 7 on measures of center. Hello, this is Rick Powers from Western Technical College in Basic Statistics. Lesson 7, Describing Data, Part 3, Measuring the Center. Our next topics involve using numbers to describe data. Even though graphs can be helpful, they can also mislead us because we respond to the visual information and geometry. However, in order to determine what is important, usually we need to know the specific value of some measurement of numbers. For example, if someone says, look at this line graph, our funding has decreased every year. That might be true, but it might have only decreased by small amounts. So then, how do we know what numbers to use and how to interpret them? To interpret data, we need the context and the relationships involved in our data, not just the values of the numbers. This is where experience often makes the difference in order to know what numbers to measure and what they mean. Big idea. Statistics alone will not tell you the meaning of a number. There are three types of numbers that we often use in statistics: measures of center, measures of variation, measures of position. And there is a concept that should always be kept in mind. Big idea. Measures of center without considering variation are bad. Consider this scenario. Our goal is to increase sales by 10% in the next year. But if you're selling items that depend on the housing market and sales of new homes decrease in your area, then you might be happy to stay in business, much less increase by 10%. It is so important to know why numbers change in order to make good decisions. Setting out a number as the right one doesn't make sense without context. Another example, if your sodium level changes every day by 10 points, then it doesn't make a lot of sense to worry if your sodium test comes out 3 points too high. Since we know that measurements are always changing, then we cannot expect any single number to tell us what to expect from our data. So measures of center should almost always be modified to include measures of variation, 10 milligrams plus or minus 2 milligrams. The standard measures of center are the mean, same as the average, the median, half the data above, half below, the mode, the most frequent data value. If we are using all the data values of the group that we care about, that is the population, then we can find the population mean. The symbol for the population mean is a Greek letter mu. Mu. The population mean is found by adding all the measurements and dividing by the number of measurements. Example, with population of 4 measurements, 11 plus 6 plus 19 plus 20 is 56. 56 divided by 4 is 14, so the mean of those 4 numbers is 14. A formula for the population mean can use the summation symbol for the adding. Use n, capital N, for the number of measurements in the population, and use the letter x for each measurement. X sub 1, x sub 2, x sub 3, etc. So the population mean, mu, is equal to the sum of the measurements, the sum of the x sub I. So that's x sub 1 plus x sub 2 plus x sub 3, adding all the measurements together, divided by the number of measurements, capital N. If our data is only part of the group that we care about, then it's measuring a sample. We still use the same method, but we use different symbols. The symbol for the sample mean is called x bar, and the sample size is not capital N, but small n. X bar, the sample mean, is the sum of all the measurements divided by the number of measurements in the sample, which is small n. Please note, although it may work for you to enter numbers on a calculator to find the mean and these other numbers we're talking about, it's very important for you to know how to use software for all calculations. It will save you much time and effort. Most of the time, we're assuming that the measurements that we're using are coming from a sample. On the homework, there may be a problem that specifically says it is a population. That will not affect the formula for the mean, but it will affect other types of numbers and formulas. The median, then, is found by putting the measurements in order and finding the middle number. If we have an even number of measurements, then we find the average of the two closest numbers. Example from the previous. 6, 11, 19, 20 in order. The median is 11 plus 19 in parentheses divided by 2 equals 15. So here's an illustration of how changing numbers will affect these numbers. What if we add another measurement of 200? The mean. Add up all the numbers, including the 200, divide by 5, now there's 5 numbers, it's 51.2. The median, 6, 11, 19, 20, 200, the middle number is 19. So which one is a better measure of the center of the data set? Actually, it depends on what we want. If we want our measure of center to be sensitive, then it will be affected by all the data, so the mean is better. After all, having a value of 200 is a big deal. The mean changed a lot because of it, but the median didn't change much. But if we want our number to be resistant, then it will not be affected by extreme values, so the median is better. After all, 200 doesn't look like it belongs. The median could be considered as a better measure of the center since it's not affected much by that extreme value. Examples of data that have extreme values would be income and real estate. So then when we compare income or real estate between two cities, most of the time we use median income and median house value. Also, it is possible to show skewness in a data set if the mean is different from the median. That is, if the median is higher, if the mean is higher, then maybe there are some extreme high values and the data is skewed to the right. However, this method doesn't always work. Dot plots, histograms, and box plots also should be considered. The mode can be useful since we may need to know what data value happens more often than other values. If we have a data group in a grouped frequency distribution that has the most data, then we call that the modal class. End of lesson 7.